All right, so today is our final day to kind of review, answer questions, talk about section 7.7.7.3, not 7.7, on Gaussian elimination and partial fraction decomposition. So I'm going to go over number 67 just to work through another improper fraction with you so that you thoroughly understand that process. And then we will look at a few problems from the Gaussian elimination problems that are assigned for tonight. Again, so that those are kind of refreshed back in your head. I'm going to look at one that's a non-square system to review how to write that ordered triple that has the A in it. Because all of the answers with Gaussian elimination that we've done with the partial fractions obviously have had solutions for A, B, C, and D. So we'll look at reviewing that. So tomorrow's test is just on section 7.3, but that includes the Gaussian elimination and applications of it and the partial fractions. The 6 review questions that I have up here should be a pretty good review to prepare you for tomorrow's test.
Are we supposed to do 69 and then another one?
Yeah, you know, you're gonna do the same one. No, I'm trying to think what number it is. I'll look. Let's fix it. Let's see. Should be 68. Thanks, Jenny. Make sure that's correct in Google Classroom too then. All right, so no, you're not doing 69 twice, or 2 different 69s. There we go, so 68. Okay. So the book problems for today, 29, 41, 42, and 79 pertain to Gaussian elimination. And then 68 and 69 pertain to the partial fractions. Again, tomorrow's test, if you decide that you need to stay home tomorrow, I'm going to consider you absent from class. You will be taking the test on Monday when you come back. So nobody in here is at this point scheduled to be total virtual. So I know some of you stay home every once in a while, which is totally your call. You're allowed to do that. But unless I have a letter from the district or from the principal saying you are now virtual, total virtual, if you're not here tomorrow, I will consider you absent and just make a time on Monday for you to take the test in person. So just a little reminder about that. All right, well, let's look at number 67 from the homework to go through an improper fraction. And then, as I said, I'm going to go through number 41 with you from that group of elimination problems, just to remind you what to do with a non-square system. So first part, before you do any of these partial fractions, make sure you're checking to see, is it improper? And this one is improper. So the degree on the top is definitely bigger than the degree on the bottom. When it's improper, Jack, what do you do to make it a proper fraction? So this fraction is improper. What method or process do we use to make it a proper fraction? Yeah, we divide. And what are you dividing here, Jack? Okay. So we're trying to break down the larger power. That fraction bar means division. So you're taking the numerator divided by the denominator. And we are going to try and divide something out of that numerator so that it becomes a proper fraction. So Jack, there is an x squared, but we're looking at 2x cubed as our first term. So what would you multiply x squared by to make it 2x cubed? 2x. And then when you multiply 2x by that trinomial, what do you get? Above plus 4x. And then we subtract those 3 terms. And they're all going to be subtractions. So just make sure that you're looking and thinking you're subtracting all three of those. So then, Jack, when you subtract those, what do you get? And then you do the process again because we have an x squared and we have a negative 7x squared. So the powers are the same. So that means you can continue to divide. So Kaden, what would you multiply x squared by to make it negative 7x squared? Yeah, negative 7. And then when you multiply with the trinomial, you end up having so once again, those are all subtracted. So we have addition, addition, and addition. And Kaden, what's the remainder here? You said 18x plus 19, correct? Yeah, just want to make sure I heard you right. So the top part, that's called your quotient, but that's going to be that part that you factored out using long division. Long division really is a form of factoring. So you're pulling that out of the original numerator. We're going to forget about it for now, but not completely because it has to be pulled back into the answer. The remainder is what's left out of what we divided by. That's my remaining part. So that remainder is going to be now our numerator. So 18x plus 19. The remainder always goes over whatever we were dividing by because that's the remaining piece. In this case, the remaining expression. Jenny, how would you factor that denominator? Yeah. So our partial fractions would be A with x plus 2 and B with x plus 1. So after you do the division, the two factors are linear. This part should hopefully be pretty straightforward. So multiply the entire fraction by the x plus 2 and the x plus 1. This one needs the x plus 1. Over here we have the x plus 2. And Jenny, when you do that, I think those are the two factors we may have had yesterday in our problem too. So the next step, create your two equations using the A plus B. Those are our x terms. And then the A and the 2B are the constants. So A plus B is equal to 18. And A plus 2B is equal to 19. So Darby, what could you do to solve for either A or B here? Yeah. And what do you get when you subtract? So B is equal to 1. And then when you plug in that 1, A is 17. So the elimination part is pretty straightforward. The partial fraction process is pretty straightforward when you only have two fractions and both the denominators are linear. So the dividing part would be the bigger part of the problem. The last step, please don't forget to rewrite this as a partial fraction with the numbers that we found. So my original fraction is now equal to 2x minus 7. That quantity was the factor that we pulled out of the original numerator. And then in addition to that, we found A to be 17. And that was over x plus 2. Yeah. And then B is 1. And that's over the x plus 1. How'd we do in that one? Good. Are there questions? So this is a pre-calc concept, but we've used a lot of algebra to work through the problem. I mean, pre-calc is like, I call it algebra on steroids. It's like amped up algebra. That's what pre-calc really is. Obviously the precursor to calculus, but I mean, it's super upper level algebra that you're working on. We just call it, instead of algebra 3, it's pre-calculus. So if you want to start a new slide, start a new assignment in Notability, I want to, as I said, go through number 41 with you. So I want to start the review with you, and then I'm going to give you time in class to work. But the problem that I want to do with you is number 41. I will also pull the problems up on the screen, but I have 2 books over there that you can then take a picture of the 2 books. But this is on page 500. And again, those problems are 29, 41, 42, 68, 69, and then 79. So I'm going to do 41 to remind you of a non-square system, because we really haven't looked at non-square systems probably since last Thursday. So this is just a little refresher. And then I'll briefly talk about 2 other problems to give you a refresher again, just to make sure that brain gets the cobwebs knocked off of it. Peter, why would 41 be called a non-square system? There's not any square variables. What else do you notice about the system, Peter? How many variables are there? How many equations are there? 2. So a non-square system, you're supposed to have the same number of variables and the same number of equations for it to be square. So in this case, it's considered non-square because you have 3 variables, but only 2 equations. Will you ever get a solution when it's a non-square system? And a unique solution? No. Because I need 3 variables and 3 equations to find an actual ordered triple that is a unique solution for a system. So if I had 4 variables, I would need 4 equations. So how would you solve number 41? What would the first step be, Peter? Sure, let's take that top equation and multiply it by 2. So we're still going to use elimination, and let's try and eliminate the x from the second equation. So multiplying it by 2 gives us 4x minus 6y plus 2z equals -4. And Peter, when you add those 2 equations together, what do you end up with? Three y plus just z. Did I?
Oh.
Yeah. And you said equals 3. There we go. So again, there is no way to get a unique solution, because yes, I can try and combine equation 1 and equation 2 together a different way, but I will never be able to get one variable to be completely by itself. So what do you do next if you can't get a unique solution? So there's no way to get a unique answer. Parker.
Okay.
Yeah. So we are going to come up with a pattern to represent the ordered triple. And that's where we start by saying, all right, well, the only thing we can try and do is assign a value for one of the variables. And let's start with z. So we'll let z equals a. So then in my equation here, we're going to plug a in for z. So Parker, when you solve for y, what do you end up getting? Yeah. And you're going, that evil fraction. So now y is -2/3 a plus 1. But of course, we need to find x, and we can find x using, it's called back substitution. Now, if you look, the second equation has an x and a y. not a z. So you could use that second equation because you're only plugging in one value. Or you could use the first one. It doesn't matter. They're both going to give you the same answer. So if I use that second equation, I have a negative 4x plus 9 times negative 2/3 a plus 1, because that's now y. And then that's equal to 7. Again, you could have used the first equation as well. I'm just using the second equation because it only contains the x and the y. When you distribute the 9 through, so we have a negative 4x. And if I distribute 9 to negative 2/3 a, what does that become? Yeah, that works out nicely. And then Hannah, what'd you do?
Then I moved the -6 to 1. -4x equals 6.
Great. And what did you get for x?
-3x a.
Again, you have fractions. It's okay to have fractions. By this point, we know we've had fractions so much in class that fractions are going to be part of your answers. So now we have our z being a. We found y by using back substitution by plugging that value in for z, and now we found x. Don't forget, your solution is an ordered triple. Even if it isn't an exact value of 1, 2, 3, you still need to write your answer pulling all three of them together. So x, Hannah gave us, is negative 2/3 a plus a half. And then Parker said y was negative, x is negative 3/2 a plus a half. Y is negative 2/3 a plus 1. And then z is just a. So your solution is an ordered triple. Grant, if I said find 3 solutions, what could you do to find 3 different solutions using that ordered triple? You could put it in a graph. What else could you do? Darby? Yeah, pick your favorite number for A. Make it easy. I'd pick, I don't know, 0, 1, and -1. But if you were asked to find an ordered triple, we all could find a different one depending on what number you want to plug in for A. But you'd start with A, pick a number for A, plug it in, and you find an ordered triple. As I said, 0 would be easy to plug in because then I just have a half, a 1, and 0. A 1 would be easy, or maybe a 2 or a 3, like the easy numbers to plug in. Any questions? So that is the non-square system. 42 is also a non-square system, so you would solve it very similarly. The other problem that I have up here that I wanted to talk about, number 69. Number 69 says x to the 4th over x minus 1 quantity cubed. This one is in the partial fraction group. There were 2 from partial fraction, 68 and 69. What's the first question you ask yourself when you look at a fraction? Cole? Is this one improper? Yes. This is an improper fraction because the power on the top is 4, the power on the bottom is 3. You will have to divide this problem, but in order to divide it, this x minus 3 quantity cube needs to be expanded first because you need to know what the polynomial is that you're dividing. So that means that, yes, it's given to you in factored form, but you really need to FOIL it out first so you know what you're dividing with. We have to have that in a polynomial because it's called polynomial long division. Right now it's factored. So in order to divide, you must know the expanded form of the polynomial. You have 20 minutes. I'm going to walk around and just make sure everybody's feeling okay. Again, you have 1 problem done. There are 5 more. 2 of them are partial fractions. The other 3 contain the Gaussian elimination. And it should be a good indication of what your test will look like tomorrow. I think there's 5 questions on the test tomorrow, maybe 6. So please work with somebody. feel free to ask me questions.